In this video, we will show you how to determine even and odd function when you are given a piecewise function. So in this example, we have two examples. So I will look at the second one. Okay. So what does it mean here in the piecewise given? So we have two values here, fx equal to -3 and 3. So we will say that on this column we take it as our fx or or can be y. Alright, so on the right side here, so we have the limit. So we have for the fx y equal to -3, we have -pi until 0. So this is our value of x or limit. Limit of x. So there are two functions where each function has its own limit. So let's plot the graph first. So we have two axes. Two axes, x and y. And then we look at the first function. So we have fx equal to -3. So y equal to -3. It occur the limit from -pi until 0. So we sketch the limit first. Because we need to plot the graph only within the limit given. So we have -pi. This is the x-axis. So the limit is in terms of x, so -pi until 0. Then we have the function y equal to -3, which is negative value. So I just put down here, we have -3. It starts from -pi until 0 for the limit. Right, so this is y equal to -3. So next we have for the second function, we have y equal to 3 from 0 to pi limit. So we plot the limit first, x from 0 until pi. So let's say I put pi here. Then we have the function y equal to 3. So it is a positive y, so it's just a straight line, right? Just a straight line. So it stop until we get x equal to pi. So this is our y equal to 3. So we have plot the graph, both graph from the given piecewise function. So next we move into the second meaning here. We have fx equal to fx plus 2 pi. So what does it mean? So it means that this is a shifting unit. So it means that the same function will occur after we add 2 pi. So that's why we have fx equal to fx plus 2 pi. So it means that the period should be in 2 pi, then we can just move it towards 2 pi units. So let's have a look for this function. So we have from -pi until pi. So if we measure the length of the limit here, we can say that it is in the length of 2 pi. From -pi until pi. So it means it is already a cycle of period of 2 pi. From the given here. So means that we just have to move. We just have to copy. So if I want to copy, so the function inside 2 pi, we just copy this one and we move forward and we move backward. So I try to move forward first. So refer to the limit. For the first function, we have only 1 pi. So we have 2 pi. And the other function, we have also another 1 pi. So 3 pi. So copy that one, we will get this is the function from pi to 2 pi, and another function occur from this point until this point. We move backward. So we will have -2 pi and -3 pi. So the same thing, we just copy that one. So backward we follow the first on the right. So we have y equal to 3. Okay, and then another one we have y equal to negative 3. Okay, it should be like this. Alright, so how do we know that this one satisfy the shifting term that defined here? Okay, so let's say we try with some value fx equal to fx plus 2 pi. Okay, we choose any value randomly. So let's say I choose for negative 2 pi. Okay, this is value of x. So I choose value of x here to be x equal to negative 2 pi. Okay, I want to see that is it same or not to the right side. So we have f negative 2 pi plus 2 pi. Okay, so equal to f0. So based on the shifting term here, we have f negative 2 pi equal to f0. So let's look at the point here at negative 2 pi. So we have at negative 2 pi, we have 2 points. Okay, up and down here. And at x equal to 0. So you look at x equal to 0, the function here, we also have 2 points. Okay, so you can with other pattern and you will see that it is satisfy the term of fx equal to fx plus 2 pi. Okay, next we go to the A. Okay, before we sketch the graph, we try to understand about the pattern of the graph first. Okay, previously we have learned about function, we have constant. Okay, for example, we have 3 and negative 3 is a constant. Okay, I put in general constant. So when we sketch the graph, it is about a straight line, right? Straight line along a value of a. Okay, so it is a straight line along a value of a. If we have fx equal to mx plus c. Okay, remember where you have learned before this. When we plot a graph, m is a value and c also a value of a constant, we will get a straight line. Okay, but not within along a value. Okay, it might be on the skew to the right, skew to the left, and so on. But it is still a straight line. We also learn about fx when we have it is a quadratic form. We have ax squared plus bx plus c. Okay, it is in the form of a curve, right? Or what can I say? It is like a smile face. Okay, sad and so on. Okay, so if we have fx a cubic, we have ax cubed plus bx squared and so on. Okay, it is there might be a multiple curve. Okay, so it just be like this, or it can be like this. Okay, there are many curves here. Okay, we continue on the function itself. Okay, so here we have two. In A we have two functions. Okay, we go to the first function. So we have 1 plus x. So I put it as a f1x. Okay, next we have the limit. Okay, so this is the limit for x. Okay, so we want to plot the graph. So since fx is 1 plus x, so it is in the pattern of mx plus c. So it must be a straight line. Okay, but we do not know which skew it rely. Okay, so maybe we can check by using, we make a table first. Okay, so I put a table. So let's say we have this is x, this is x, this is fx. Okay, so let's say we have the limit here from negative 1 until 0. So we choose negative 1 until 0. So since this is a straight line, we just take the initial and ending point. Okay, because it is only a straight line. So x equal to -1, x equal to 0. So fx here 1 plus x. So if you use calculator, -1 we substitute into x, we get 1 minus 1 0. Then 0 into substitute into x, we get 1. Okay, so we get the point here is -1 0, and another point here is 0 1. Okay, we sketch the graph here for x and y. Okay, so x here we have -1 0, so x -1 -2, so 1 2, this is 1, this is -1. Okay, we have the point at -1 and 0. Okay, so it should be like this. Okay, at this point, the first point, and then the second point we have 0 1, so this is 0, and the y is 1, so we get the point here. Okay, so since fx is a straight line, so we just put the line here. Okay, so we get the line of 1 plus x for this limit only. Okay, so next we continue on the second function. We have y minus x. Okay, so the limit here from 0 to 1. Okay, so we can plot for a second function. So this is second one. So we have 1 minus x. So we choose the point must be within the limit. So 0 to 1. Okay, so gantikan. So we need 1 minus 0. So we get 1. So 1 minus 1, we get 0. So we get the point is 0 1, and another point is 1 0. So 0 1 is here. So 0 and 1. So we get at this point also. Okay, and another point we have 1 0. So 1 0 is at this point. So there are 2 points, so we can connect it with a straight line. Okay, so we get 2 function sketch on the graph. Okay, so since there is no shifting function, so we don't have to move that function. Okay, these are the proper solution on the previous example that we have done so far. Okay, so as a summary, so what we have learned from here, we have learned about the even function. So the characteristic is the symmetry is to the y-axis. Okay, for the odd function, it is symmetric to the origin. And odd function also, it can reflect on both x-axis and y-axis. And we also have learned about how to sketch the graph, okay, when given a function or a value of limit and so on. Okay, so next we will continue on finding the Fourier series. Okay, thank you.